So in this video, I just want to walk you through some optimizations when you're making cuts on the laser in Rhino. So this is just a drawing that I've downloaded from Thingiverse, and you can see here the original author that created this document, and this is very typical of a Thingiverse kind of document. So looking at this, some things right away that you're going to notice, these have been grouped. This happens to make the Doctor Who TARDIS. What we have here is a side of it. This square right here actually goes behind the window pane here, and then there's actually another square that goes in here that goes behind these panels. So these are actual part, and that's a good thing that they're using their space well, but we're still a long ways away from optimized here. So some things that we want to correct just right off the bat. First off, before I start working on this, I'm going to select everything and then I'm going to explode it so that I can start working in it. One of the big issues, and if I can give you one big hint on things to change, this is one. If I click on this line, notice I have the option of two different curves. So what's going to happen here is the laser is going to come across this area twice, and pretty much everything here is just a vector cut. These are all designed to be cut through. There's no rastering in this particular file. So this is doubling the time it takes to cut because the laser doesn't know to only cut this once. So if I start looking through here and inspecting, they've done fairly well. Here in between, I'm definitely getting two lines, and that's where they've taken this object and put it beside the next. Haven't tried it yet, but I bet if I click right here between these two, yes, I get the same thing. I'll get the same thing over here. Notice there's two curves on top of each other, so all of this cut through here, not only is it a wasted time, but you'll actually burn your material because the laser's cutting through twice. So first step is to go through and select these and delete the second curve. Also on this one, if we zoom in, I've got this little stray line up here, and that's where when they brought these together, they didn't use snap points. So let's go and inspect this corner, and you can see here these items aren't actually touching each other, which again will become a problem. So to fix this, what I need to do is delete this line and then extend this line over. Additionally, anything like this inner curve, I'll probably have to explode that line so I can get the individual lines. Let's see what they've done here at the top. So that's pretty clean. I was wondering if these two were actually joined, but I think they were just grouped. So I would want to probably select these lines and group them together so that the laser makes one continuous pass around in a U shape like this, not run a line, stop, run a line. Remember, with vector sorting, it may cut this line and then move over here and cut a different line. Along those same idea, when we're cutting internal panels like this, like these windows here, one of the things that I don't want to happen is I don't want the outer shape to cut, fall away from the material, and then the laser go and try to cut these inner pieces. It's going to cause misalignment. If your original material isn't dead flat and there's a space between the table, you cut this outer shape and then it falls down flat onto the table if there's any height to it, and then it tries to cut these inner shapes and it causes problems. So this is a great example of a place to use the color mapping. I would actually come through here and color map these and vector cut them before I cut my outer shapes. So I'd probably do that here. I would do that in a square like this. This actually a little piece here is being used as part of the model. So is this one. So I'd want to cut the circle first and then this outer edge and then the outside piece of it. We can also get these much closer, so there's no reason to waste that space. Overall, one thing that I want you to look at is notice how all of these lines, these long linear lines going this way, if we take and rotate this entire model, so now that we have this model rotated, all the lines going this way will cut much faster because of the orientation with the x-axis. Remember, that x-axis really is a lot faster than the y. So anytime we can run those side to side, that's going to be a big change for us. Another place to kind of look, let's look at these little cutouts, and what these are, they're supposed to be cutouts for the ends of these tabs to fit in. So this bottom piece and this top piece hold these side pieces in place, but you can see here the original author of this did a very bad job about just overlapping these. So a quick fix is just use the trim tool. We're going to select everything and then cut out. So now that's going to look much better. And we've probably reduced the cut time on this one little piece by 50% or more. And those little things matter. And then we need to go back and join those, which will make the laser cut it even faster. So anytime we have a shape like this, we want it to make sure we've joined it. We make sure there's no lines that we don't need to cut. There's no overlapping lines, even to the point of grabbing it and moving it to make sure there was nothing underneath of it. Those little kinds of tricks really make a difference with this. Another issue that you want to think about, if I go in here and I'm going to zoom into this, so these are tabs for a piece of the material to go into. So I want to go into dimension and I'm going to dimension this, and this drawing is in millimeters, so this is spec'd out at 3.244 millimeters. One thing would be to convert it over to standard inches unless you really like to work in millimeters. The other question here though is, where do I find 3.244 millimeter material thickness? You're going to find that most of these you're going to have to redraw stuff like this to match whatever thickness. If it uses tabs, we're going to have to change the thickness of those slots to fit whatever material we're cutting. So if you wanted to do this in, say, mat board or something like that, you'd have to change those. And if we look over here, this author actually has listed that it's 3 millimeter material, but that means they've given a lot of slop room. Now, it may be that they did that to account for paint or that type of thing, and I'd have to kind of play with it to see if those are too narrow, and also if I can get 3 millimeter material. So overall, the things to think about: watch duplicate lines, watch the cut order of things, watch redundant lines or lines that don't need to be there. Make sure you group objects and make sure you move objects as close together as possible. Also make sure you reorient the drawing so that it uses that x-axis to be a little faster. And it may be that we move this around and reorient it because our laser cuts a 24 by 36 platform. We may be able to get these into even a smaller space. If we're cutting, say, 2 of them, there might be a way to orient the different pieces in a 24 by 36 area that takes better advantage of that workspace than whatever space they used in this one.